Are you all doing? Hello, everybody. You're welcome to part two of the capstone project walkthrough. So during the last session, the last class, we looked at how to build a prediction regression model for UK used UK used cars. We want to predict the car prices of some UK used cars. And then we worked on this Jupyter notebook. We will just be doing a quick wrap up of the last part of the class. And then this class will be focused more on improving the performance of the model, as well as building a front-end interface where other people can interface with it and interact with it. All right. So in this class, we've actually gone through building of doing the model improvement and also the front-end interface. So I'll just go through the explanation of how to go about it if you are to do one, or if you are to replicate this project. Okay, so the data set, I'll just do a quick recap of the data set and then the processes we went through and where we're starting from today. Okay, so it's an 100,000 UK used car price prediction. And the data set was gotten from Kaggle. This is the data source here. And we had over different brands of cars, like almost like 14 brands of cars, but we had to focus on just 5 brands in this project. So we had the Audi data set, BMW, Ford, Mercedes-Benz, and Toyota. Okay, so what we did during the last class, we did some data exploration. Afterwards, we did after exploring the data, we had to clean the data. So there were some duplicate values there. We had to tidy that up, as well as we had to check for missing values. Then afterwards, we did some exploratory data analysis here. And we had to check for the relationship between other features and our targets. In this case, our target is price. We want to predict the price, but given the model, the year, the transmission mileage, fuel type, tax, MPG, engine size, the manufacturer column was created by us because we had to include that just to label each of those data sets that we merged together. We had to merge the 5 car models together into one single table. And in order to know which car record belongs to the particular manufacturer, we have to create the manufacturer's column. So all of that was explained in the last class video. Okay, so you can take a look at that first before coming to this point. Okay, so we did some pair plots, and then we also did some visualizations just to check for correlations and relationships between the features and our targets. During the last class, we were able to train a linear regression model, and we made some predictions with an R score of 0.74. And then we explained how to save your model as a Pico file and how to reuse that to make predictions. Okay, so that was what we did during the last class. So this class, we are going to just look at how to improve the performance of this model. What other things can we do to reduce the error and increase the R score, and as well build an interface for the model. So the first thing we did was to select just the numerical features. So when we were building, when we imported the data sets, we had this is the data set that was imported, meshed together. So we had the model, year, price, transmission mileage, fuel type, tax, MPG, engine size, and manufacturer. Okay, so we had to convert all of this, the transmission, fuel type, and manufacturer, into one-not encoding formats so that we would convert them into numbers such that it would be a good input for our machine learning model. But then that was what we used to build the linear regression model. But then let's try another approach. How about we just using the numerical features alone to build our model? Will that affect the performance of the model? So that's the first thing we're going to try out. And to do that, you have to start from defining your features. So here we have our features defined. Let me get to the section. Okay, so here we have our feature defined, the X and the Y features. So we have the mileage, the tax, and MPG, engine size, and age. These are the features, and as well as our Y variable was also defined. Okay, so then we imported model, the train test split. We have to split the data set into the training test and test. So it's still the same process. The only thing we are just changing here is just the features that we selected. And after we built this model, we did our prediction and we checked the error. We noticed that the R² dropped, the error increased. So this obviously is not a better improvement against the next one, because without we going this route, from our data analysis, we observed that features like the manufacturer and the engine type all had an impact on our price. Like, this is the manufacturer and the price visualization. So from here we could see that Mercedes-Benz had more, it was sold at an higher price. So that gives us a good indication that manufacturer could be a good predictor, right? So we have to include that in our data set. So what are the other approaches? We could try other algorithms to build our data set. So in this case, we're going to try the XGBoost model. So for the XGBoost model, you have to import XGBoost as XGB and then import XGB regressor. So XGB regressor is a very good algorithm that you can also use to build a regression model. So the process is still the same. We're going to use the features that we used to build the linear regression model that gave us a 0.75 R². So here we're going to define our X and Y, and then we're going to do train test splits, instantiate our XG regressor. And so here we had some parameters that you can declare, you can tune. So by default, the XGBoost model has lots of parameters in here, like this one. Okay, I'm going to just navigate straight to where it is. Okay, these are the other parameters that can be tuned. So we're just going to set our objectives to a reg linear. So to say that, okay, we want a regression linear model, and then we're going to fit it with our training set. So we're going to fit the model with our training set. Afterwards, this builds our XGBoost model. Then after having built our XGBoost model, we have to make predictions so that we'll be able to build the error. So that we will check for the error. So after making prediction, you have to import your mean squared error, mean absolute error, R². So we are using the 3 errors to benchmark our errors to know which one actually would give us the best. And then there was a whooping jump in our R² and even in our error, with big reduction in our error. So here we have 0.916 accuracy, which is a very great improvement. Okay, so that tells us that we are making the good progress. So, but this can be further improved. There are so many other things that can be done apart from what we just did. Okay, so another thing is to try other models. So before you use the XGBoost model, ensure you install it, because if it's not installed, it might throw an error. You could just pip install XGBoost on your Anaconda prompt window. Pip install XGBoost on an Anaconda prompt window. So it's something like this. So you can just pip install. I've installed it already, so I'm just showing you the interface. Pip install XGBoost. Open a new Anaconda prompt window, install it. After installed it, then you can now use the model. Okay, so let's get back to our notebook. Okay, moving forward, we can also try to train a decision tree model. So all of these models, they have their libraries. So from XGBoost, we have to use the XGBoost library, but from decision tree is part of sklearn.tree, so you can import it from sklearn.tree, and then you define your X and Y, and you do your train test splits. Afterwards, you define a decision tree regressor. That's the one that was imported, decision tree regressor. You can set the random state to any number, and then you fit your data sets with your training sets, your train X and your train Y. After fitting, then you can now make your predictions. So when we made our predictions and checked for our errors, we discovered that there was a reduction in our R squared. So obviously the XGBoost is still giving a better result compared to the decision tree model. So another thing you could do use some feature selection algorithms. You could use your in this case we tried the mutual info regression. So in our previous classes, we explained how to do feature selection for regression models. So in this case, we have the feature selection. You have to import the library sklearn.feature selection, import mutual info regression, and select XKBoost. So this is what you're going to use for this feature selection process. And to do your feature selection, we created a function, the select feature. So the function takes in the training set, that is the X train and the Y train, and then the test set apart from the Y test. So takes in 3 parameters, and then we define our instantiate our select k-best and set the score function to mutual info regression. And then we set our k to all, that is, we want it to give us all the scores of all the features. We want to know the top features in our data set. So you're going to fit this feature selection model to your training sets, and then you can now transform it on your the feature selection model, this FS that you fitted, you can transform it on your training set to have your X train feature selection, and also transform it on your test set to have the X test feature selection, and then you return the results. So this function is what we are going to use to do our feature selection in our model development. So here we're going to define our X and Y, and then we're going to do our normal train test splits. Now, I haven't done our train test split because this feature selection algorithm, function has been defined. So to define the X test and the Y test, X train X test and the feature selection, we're going to use our select features function, which takes input of the X train that has been splitted, the Y train, and the X tests. Okay. And then when we do that, it's going to give us some values. It's going to give us our F scores, our feature selection scores. So we're going to create a data frame. We can either print all the scores if you want, but then to put it in a very more presentable format, you can just save it into a data frame called DF scores, and then you create a data frame of the X columns. So that is all the columns in our data set. All right, so having done that, you can now concatenate these two data frames together to give you a table. So you can see that here we're having our features and our score on a table. So what you're doing here is that you want to print the 10 largest score or the 15 largest score. So here we printed the 15 top score, and here you can see the MPG, engine size, age, mileage tax, and all of the top features. So having gotten those features, you can now use it as an input to your machine learning model. So in this case, we're going to try the XGBoost that we've used earlier because that gave us the best accuracy score. We want to improve on the XGBoost model. Okay, so we're going to define the new features that our feature selection algorithm had given us as the top 10 as our Y, then the Y as the price. We do your 10 train test splits. Haven't done your 10 train test splits, then you define your XGBoost regressor with all the parameters, then you fit it to your model. haven't fit the training set to your model, you have your model already developed, then the next thing is to make your prediction. So we're going to make prediction by setting XGBoost, XGBR dot predict on our test set, and that's we have our prediction here. So to do your evaluation, you can use your mean absolute error by comparing your test sets with your predictions, okay, for each of the evaluation metrics, and this is our result. So let's check. All right, so the error dropped from 0.916 to 0.90. So that means it is that we have to select more features. Okay, maybe the features we selected were too small. All right, or maybe we have to increase the number of features. Maybe we do top 15 now in this case, instead of using top 10. Probably that would increase our performance. So there are several other things to do to improve the performance of your model. We could try other algorithms. We could even tune the parameters in our XGBoosts. All right, or we could also try other feature selection models, or we could do some feature engineering. But at this stage, let us proceed to build a front-end interface. So we're going to finally settle for this model that gave us an error score of 0.916 and 0.2, which is better. That's the best model. So to use this model, we have to save it as a Pico file. And to save it, you have to import Pico. Then you declare the file, you define any file name, whatever you want to name your file, right? You can define it. In this case, I named it xgb_model.sav. Then there's a pico.dump function that you can use. Then you give it your XGB, or that's the name of the model. Now, the model that we built is XGB_R. So depending on the model the name that you give your model, and then you have a comma, open file name, and then the right of the file. So when you do this, this automatically saves it on your local directory. So let me just navigate to my local directory to show you where it was saved. So here you can see that the xgb_model.sav has been saved on my system. Okay, so what is the next step after this? What do we do afterwards? So the next thing to do is let's build the front end for this application. And to do that, we are going to make use of our VS Code environment. VS Code is a great tool. I mean, it's an IDE where you can build front-end interfaces, and also you can also use it with Python library. Okay, if you don't have it, you can download it from Microsoft. It's a Microsoft product, and then you can also we are also going to use Streamlit for building the front-end interface. So Streamlit is a very powerful application. It's a Python package library that was built. Instead of you going through using Flask or Django, and then you have to have your HTML, CSS, and do all of those web framework. You can just use Streamlit to build the front end without having to write so many HTML and CSS code. So I'm going to show you how to build a simple interface for this model. I mean, for users to interact with. So the first thing, like I said earlier, I've done this before. The video file got corrupted, so I'm just having to do the recording over again. All right, so you have to create a folder for the project. So if you've created the folder here, I'd already created the folder. So I just went to the location where I created the folder, and I opened the folder, and the folder was called UK Cap Price App. So this is the folder. So I selected the folder, and then it opened this interface. So in that folder, I have my my XGBoost model, maybe it's some images that I want to use, and then the CSV file that I used to build my model. And then I created a new file called car_app.py. So car_app.py is the new file that I created. So when you create a new file, a .py file, so assuming I want to create a new file, and I just name it something like this. Just click this plus and name it car.py. So this is what happens. It brings another interface and you can start writing all your code. But then I've already written the codes here, so I'm just going to run through it. The first thing is to import. Do your import Streamlit as ST. So if you have not installed Streamlit, you need to install it. You can just go to your terminal, open a new terminal. Here I have a terminal open, so I can just pick anyone I want to. So in this case, I want to use my command prompt. So under your command prompt, you can just do pip install Streamlit. I have it installed already, so I'm not going to run it. I have it installed already. So I haven't installed it. This wouldn't throw an error anymore. So you have to import pickle. The pickle file is what you're going to use to load your model. Pandas, I'll be using pandas. Image is to use to load your image, and then the sklearn metrics in case I want to calculate my performance metrics. So the next thing is to load my model. I have to load my model. Load my model. I define my file name. Where is this image stored? Okay. Okay, so the model is stored here. So I'm just going to right click and to copy parts. I haven't copied the parts. I paste it. When I paste it, I'm going to have it like like this format. But then I have to change it to a front is it a front or a back now? You reverse the slash to a forward slash to a forward slash, okay? Everywhere you say backward slash, reverse to a forward slash. That's going to be the file name, all right? Then you're going to use your load model, that is the name. You give it a variable, the name of your model. Then you're going to use people.load open file name, comma, RB. So this loads up the model. Now you have your model already on on this notebook. So you can use it to make your predictions when you want to. So the next thing is to define a main method. When I define the main method, I can use my def main into brackets, bracket then full colon, and then I have to close the method under here by saying if underscore underscore name underscore underscore double equals to in quotes main. This is underscore underscore main underscore underscore full colon then main. So this closes the main method. So I can now put in all my instructions into this main method. Okay, so here I can define my title. This is the title of the app. So I can just also navigate to the front end. As I'm building the model, I'll be showing you the front end interface. So to run this app, I can just say Streamlit run. The name of my application is car underscore app.py. Okay, so when I do that, it's going to open the browser automatically for me. And then I have it opened here. So you can see that they have it opened. All right, it's still loading. This is still loading. Let me just share this page. Yeah, it's great now. It's opened now. So here you can see the Streamlit application. So this is going to be the final results, but I'm just going to explain to you how everything came up. So this place is the heading of the of what I just what I just showed you, the code. So I'm going to navigate back to the VS Code. All right, so we have the title, which we just saw in the bold. So I'm just going to explain how I got about the came about the interview. Then we have a markdown. So when you do your markdown, markdown, you can choose your 3 quotes and then put all your messages inside. Welcome here. You can find out how much to sell your used cars or anything you want to write inside your markdown. It can serve as a markdown interface. So that was done. And then here I wanted to just view my data set. So here I'm going to read in the data set using PD. That's the pandas. That's why we use the pandas. Pandas.read_csv, carprice.csv. That's the CSV file that we used to build the model. And then I set the index column at 0. So here I can use st.write to show the sample of my data as text, then st.dataframe to show the first 5 records. So when you do that, this is what you're going to see afterwards. You're going to see this is it. You can see this is the markdown that was done. This is the st.write, and then this is the sample data set. So here, that has been tied up. So we're going to create a sidebar. So you can decide to do your interface anyhow you want it, but then I want to create a sidebar. Then I want to have an image here. Then I want to have the model as a drop down. That is, there are some when you're creating your front end, you have to collect input from the user that would feed into the model so that the user can click on the button and then a prediction occurs. Okay, I'm just using this as a use case in this part. Maybe you're building an application. There are some model integration that they are not really front-end interactions. Maybe they're going to be used within the processes of your software development. But in this case, you want the user to interact with this application. So you have to collect some inputs like the model of the car. Now, when you're collecting the inputs, it's not necessarily all the information you collect from user. That's what you use to feed into your model. You're going to feed in the model with just the features that you trained the model with. We had the option of using feature selection to select maybe like 10 or 15 features out of the total number of features we add. All right. So if you're eventually set for 10 features, those are the features you just collect from maybe if you're collecting even maybe 100 records or information from your user, you're going to just use those 10 features as inputs into your ML. All right. So I want the model to be a drop down. And in this case, I want it to load the drop down from my data frame. I don't want them to just input any model. I want them to input the models that have already been in my data frame. So I'm going to show you how to do that. All right. Also, I want them to select the year, not previous year. I want them to select the year within my data frame or my database. Also, the transmission, I want it to be a select. Then the mileage, the tax, I made it a slider. And then I also made the fuel type a drop down. That is, it could be petrol, the diesel, hybrid, the manufacturer, and then the age. I just made it a text so they can write any age. All right, so let's get back to our code environment. Okay, so here, this is where we want to collect the user inputs. So for me to have that sidebar, I had to use the Streamlit with st.sidebar function. So when you do strip with st.sidebar full column, everything inside this with statements from here would all be in the sidebar. Okay, so you notice that everything there will be under the sidebar. Then this is the button on the main page. So this is not inside that with statement. So I'm going to show you how I came across those those sidebar features. So the first thing I have is that image. And to use the image, we remember we imported the pickle from Pillow, import image. So we're going to use the image. We're going to create a variable called image or any name that you want to give it equals the image dot open the name of the image. So I have an image already in this directory called car.jpg. So I'm going to put the directory name and then give it the image. Then I can set the image width using st.image, then the name of this image. Then I'm setting the width to 200 or whatever width you want. So that is how to create the image. And then the next thing I wanted to do, I did was to create that drop down, you use the st.select box. So I'm going to give all of those Streamlit features, I'm going to give them in variable names because I'm going to use this inputs in my model that I want to predict. So I'm going to collect the select box, create the select box using the st.select box. Then the name that I want it to I want the select box to show to the user. This is the model, comma, then this is the drop down values. So the drop down values, because I want it to be from my data frame. So I did I'll just select a single column in your data frame. That's DF model, right? Then because I want it to be the unique values, I'm going to do a value count, .value count. Then I just want it to be the name, not the number of the value count. So that's why I have .index. So using this, you're going to have that in a drop down. I did the same thing to the year as well, transmission. Then for the slider, you're going to just use the st.slider function, then the text that you want the user to see, and then you're going to define the minimum, the maximum, and the mean values. In the slider, you had a minimum number and the maximum number, and then the default value. So to get the minimum number, I'm going to use the minimum value inside this mpg column. So to get that, I did df.mpg.main. All right, that gives us the minimum value in that column. And then to get the maximum value, df.mpg, mpg is the name of the column, .max is going to give the maximum value. And then to get like a default value, I can either write in any number or I can just get the mean. So whichever way you want it. So I'm going to just get the mean of the value. So that's giving us the values on our slider. We're going to do the same thing for mileage, tax, and fuel type. So let me just show you what the MPG looks like. I'm going to show you what the MPG looks like really quick. So you can see here, this is the MPG. Select MPG as the name, then this is the minimum value, the maximum value, and then this is the defaults that we have on our record. All right, so let me show you other features. So we have, you do the same thing for mileage, tax, fuel type is a select box. I explained already how to do a select box, right? Then these other ones are select box. Then the age was just the text inputs for users to just set a text, and I use Streamlit the text inputs. Then the name you want the user to display, and then the default value as well. Okay, so now I haven't set all the inputs for the user. We want to put a button. So we're going to use an if statement such that if this button is clicked, all of these things should happen. So we are simply going to say if st.button, the name of the button, predict car price, okay, full column, then everything under this if statement from here to here, right, would execute when that button is clicked. Okay, so we have the first thing is the inputs that we collected from the user. We're going to create a dictionary for that input, because collecting those inputs from the user, we have to transform the data into what our machine learning model used for prediction. You remember that there were some of the columns, like some of this are numerical values, some of them are string values. So we have to convert the string to numerical values. So to get those data, we create a dictionary. So for each of the data that we collected, like the mileage, the ones, now we are not going to use the model in our prediction. So I'm not going to include model in the dictionary. I didn't use year. I didn't use year, so I'm not going to use year in my dictionary. But I use transmission, MPG, mileage, tax. So those are the values I'm going to add to my dictionary. So I have the mileage, then as the name of the key, and then the mileage that the user supplied, the tax, and all other values. As well as after creating this dictionary, I put it in a data frame. So when I put it in a data frame, using the pd.data frame, the input data, and then set an index, I have a new prediction column on my data frame. But this data frame has to be encoded. We have to convert all of the numerical features into all of the string features into the numeric. So now let me just click the predict price because I've already built it already. So this was what the user supplied, right? But after this is age, under transmission manual, the user supplied the manual, but this had to be converted to value. So that's why you see that after the encoding, we have this number 1, field type 1, manufacturer 1, and all other values 0. Okay, so this is what we are trying to achieve by converting it. Okay, so let me just explain the other parts. So you have, after creating that data frame, this is the encoding. So we have to declare create a list of all the columns that we want to encode: the transmission, the fuel type, and the manufacturer. Manufacturer has about 5 categories. A fuel type has like petrol, diesel, and other fuel type. And then transmission, is it electric vehicle, is it manual, is it automatic, and all of that. So these are the columns we want to encode. So we're going to do a for loop whereby we want to create dummy variables for each of this column. So we're going to say for call in this encode, for every column in this list, create a dummy using pd.get dummies. How do you create your dummies? Normally when you want to create your dummies, you have to give it the column name, that is the column that you want to create. Then we want to set a prefix so that it's going to give us the name of the column will have a prefix. So that's why we have this prefix. So we have this as a dummy. So after what the for loop does is it creates all the dummies for the transmission, fuel, and manufacturer. And then afterwards, we can concatenate it with our original data frame. And then we can now delete all of these transmission, fuel, and manufacturer columns because we don't need them again. We only need the transformed data. All right, so that's why we have to delete the df.car columns. So when we do that, the data frame you saw in the front end, this is it. All right, so that's the final result you're going to see. But now that is the result we're going to use for prediction. So the next thing is to make our predictions now, since we have the values transformed. All right, so to do that, I'm going to extract the names of the columns, all the columns. We're going to extract all the columns and the values because we're going to use that to make our predictions. But before we make our predictions, the model that we built had other column names apart from what the user supplied. There are other column names apart from what the user supplied. So we're going to create a data frame that gives all the other column names a default value of 0. And then we're going to update this data frame with these new values. That is the new data frame that was created, this new data frame. Let me go back to the front end so that you're going to see it. So this new data frame that was created, we want to update all everything. This one we're going to update it with what's with the inputs on our model. So everywhere you see your like in the model, right, we have manufacturer, BMW, we have all the other ones apart from this. So let me just print out that particular table so that you understand what I'm talking about. So if I'm going to print it, let me print this df.predict so that you see what I'm talking about. st.write df_predicts. Okay, so this is slightly outside, so that's why it's showing an error. Okay, so we're going to have this. So let me refresh this so that you can see what I'm talking about. So I'm predicting now. So under predict now, you can see this is the table, the original table that should be an input for the manufacturer. So this information that the user supplied has to be updated on this table. So if you go to this table now, you can see that this table is has been updated to what? So we all have 0 on this table, right? So but let's go back to after the update, you see that some parts are 0, some parts are on, I mean, like mileage will become 100, tax will become 50, and other parts will be 0. All right, so that's what we're trying to achieve by creating the new data frame. So now this is the data frame we created. Now having to update the prediction with user inputs. So when you update the prediction, how do you update? You have to just select the car names and then the values, and then use it to update the record. So when you update it, let's print this new data frame after the update. So let's print it so that you see what happened then. Right, df underscore predicts. So you have this. Let me save it quickly. And let's navigate back to our front-end interface. So here, let's do predict again. Now you can see that mileage has been updated, tax 50 mpg, age, transmission, the transmission automatic. Now you see transmission automatic, it was not part of what the user supplied, but because it's part of our prediction, it has to be included. Okay, so transmission automatic is still 0, then other things the user supplied, they are what? 1. All right, so we are gradually coming to the end of our interface. So afterwards, we can now make our prediction with that new table. So when you do prediction equals load model.predict. How do you make predictions? Your model name.predict, then the what the user supplied. Okay, so let me just comment this out because I'm not ending it. Then after the prediction, it's going to predict the value. I want the value to be rounded off to 2 decimal places, and that's why I have to round it up to 2 decimal places. Okay, prediction, then I had to select 0 because it's going to give me an array. So the first element in the array is 0. So that's why we have prediction square bracket 0. And then you can now write out your results. You can sell your car for output. And so when we do this and we run it, let's see what the results would look like. So here, I haven't done that. Let me comment this table out too because I don't need that. So having done that, let me go back to the interface. Okay, here on the interface. So let me just reload this. And then you can see here that when we select our model, we select auto transmission or semi-auto, then the MPG, we select the age. Let me just say 3. All right, then we can now click predict car. And you see that you can sell your car for 23,624.47 pounds. It's a UK car. So here you see that we built a front-end interface for it. So this is just the minimum products. You can do so many other things with it, but for the sake of presentation, I'll just stop here, and then for you to just explore other ways of creating and making the interface more robust. And then most importantly, you are particular about how accurate your predictions are. How accurate, for example, someone that wants to sell his or a car should have a particular confidence level that in your application that, okay, of this social confidence level, I'm sure that this price is the price, the market value for the car I want to sell. All right. So thank you so much for listening in. I hope you learned 1 or 2 things. So at this point, we're going to call it a wrap. Enjoy the rest of your day. Bye for now.